Here we go. We have a question, word search. So you have given a 2D matrix of n cross m size and containing English alphabets and a string word. We need to check if word exists on this matrix. The word can be constructed by using letter from adjacent cells, either horizontally or vertically. So we are free to move in all of the four directions. The same cell cannot be used more than once. So this is one criteria. We have a word geek. So we will start from this, then we go upwards, then in this direction, then downwards. So we found geek. The answer is true. Geek can be found in this matrix. Then we need to find geek. So we start from here. Then we found E, but then we cannot found the next E. So the word cannot be found. The answer is false. In this we want to construct B, AB. So we can start from here. Then we can go downwards. We found B, so this is possible. We can also go in this direction. This is also possible. And AB is found. So the answer is true. Now let's build the approach. Let's say we have given a matrix. So let's say we have given this matrix and we need to construct A, M, O, P. So we have not found A, then we found A. So we found A, then we try to go upwards, but we have found C. The next character we want is B, is M. So we cannot found M if we go upwards. So if we try to go on this direction, the character does not match. We need to find the next character is M. We need to find M. So it does not match. Next we need to find O, but it did not match. Then we found M. Yes, we have found M. The next character is O. We need to find O. So if we go upwards, it did not match. We can go in this direction. We found the next character, and its next is P. So we try to go in this direction, but this is out of bound. Then we try to go in this direction. We found P. So we are free to move on any of the four directions, and we need to construct a letter. Now let's say I need to find let's say O, M, O. So we start from this. We found O. The next character we want is M. In this direction M is not there. In this direction M is not there. Okay. Then we start from this. It is D. Okay. Then we found A. Okay. Then we found O. Yes, we found O. Then we try to go upwards. It did not match. It did not match. It did not match. It did not match. And we try to find the character from the next index. So it did not match. Next we found a match. So we match a character. Then we try to go upwards. Did not match. Then we try to go here. Yes, it matched. The next character I want is O. But if we go upwards, it did not match. If we go here, O is matched. So O is matched. We can take this, but a cell can only be taken only once. A cell can be taken only once. So we need to handle the situation. There are two ways to handle this situation. One way to is just create a separate boolean array it will tell us whether whether a index is previously visited or not. So m is here, first O is here, we will mark this, we will mark m also, the next character is O, so we try to go here, but this it is already visited, so we will not visit this again. One way is this, or another way to handle the situation is to just modify the input array itself. So I try, so let me erase the characters here, and I will show you what else we can do instead of creating a separate array of boolean. So we have O and M. We visit this, O is matched. Then what I will do, I will first save this O. I saved this O. Then I will change it to some special character, let's say hashtag. Then we try to go and find next character. Next character is M. So M is matched. So we will store M on this stage, and I will add hashtag, and I will call the next recursive call. I will do the next recursive call. It will pass to the next neighbor index. It is already visited, or we can say character did not match. O does not match with hashtag. O does not match with this or this. So on this stage it did not match. Then just put the previous character itself. The previous character is stored on that stage of recursion, so we can directly place the value. Then we have found from this index, this path is not possible, this path is not possible, this path is not possible. Then we try to go on this path. This path is also not possible, the character is not equal to M. Then what we will do, we will directly place the character here that we have stored on that particular stage of recursion. So we will place O, move to this index. Can we start from here? Can we start from here? No. We cannot start from here also. Then we can start from here. Then just place the hashtag and try to find the next character. M. Is M there? No. M there? No. M there? No. M there? No. So place the same character. This is called backtracking. And start from the next character. Can we start from here? Is this a correct starting point? No, it is not. And that's how it will work if we have filled all the value. So what I will do, I will start from every I, and I will start from every j, or I will start from every I and j cell, and try to find whether the character is equal or not. So I will also pass the 0. It denotes my index in string s. If I find all the character matched, if every character is matched in string and every character is found in a matrix, then my this index, I will say it id. If my id reaches string length, so the answer is true, we have found the string. So that's how it will work. Let me show you the code. So we have nm, we have I and j, we have a solve function passing I and j, also passing nm, matrix itself and starting point. So it denotes the id for my word, and also passing word. This is just my direction array. I have a function ij, nm array, id and word. If id is equal to word, then return true. It means every character is matched in word. If this is an invalid index or the character does not match, return from this stage. Else the character is matched, save the character in this recursive state and change it, so we will not visit that stage again, that index again. then we will try to find the next character in the adjacent neighbors. So add xth value in your current I and jth value in your current j, so it will give me the neighbor index. I am also passing nm, and id character is matched, so pass id plus 1, and if that path returns true, it means the remaining sub array or sub word is found, so return true from this stage also. Else this path is not possible, so do the backtracking part. Just put the temporary variable that we have stored on this recursive state. So this path is not possible, return false from this stage. So that's how this function will work. So if any of the I and j starting point is possible, it will return me true. If neither, if we have not find the word in our matrix array, it will return me false. So that's how it will work. Let's submit this, and let's talk about time and space complexity. So for this function, the time and space complexity is a little bit complex, so pay attention. So let's say my ij is my starting point, so I have 4 paths from this cell. So I have 4 paths. So we have 4 path, and what will be the maximum length of a path? So it will reach till we have a word. We need to find a word, so till we have a word. So let's say word length is L, so it will be 3 raised to power L, and I will try to find for every single, so I will consider the index. So I will consider I and j as my starting point, and I and j, what will be the I and j? So this will be my starting point, this will be my starting point, this will be my starting point. So how many these calls will be made? So it will be made n cross m. This will be my matrix. So this is the total time complexity. Let's talk about space complexity. So we are doing a recursive call, so how much depth we need to go? It will be order of L, plus we are not this is a recursive path, recursive stack, and apart from it we are not utilizing any other space. If you made a separate boolean visited array, so it will be n cross m size, but I am not making a separate array. I am just changing the input array and placing hashtag in place of a word, so I will not visit that cell again. So no more space, because we are we are doing backtracking, and that's it. This is my time and space complexity, and the time and space complexity is given here. So n cross m multiply 3 raised to power L, but I think it should be 4 raised to power n, and space in our case is order of L, which is recursive stack, and n cross m we are not utilizing, and we are not making any separate visited array. So that's how it will work. The code is provided in the description box. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching this video.